Welcome, people, to the student experience presentation on heat exchanger. My name is Abhishek Rajbhandari, and I'm currently doing bachelor's in mechanical engineering from City College of New York. This is basically a laboratory experiment performed during this semester, spring 2016, as I do not have a real project under me and do not have an experience working in a project. So this topic in this presentation, we're going to describe what is exchanger is and why did we perform this experiment and methods used to perform the experiment. Then in short we'll discuss about results and conclusions. We all know that thermal energy between fluids, transfer of thermal energy between fluids is an important phenomenon which is widely used in engineering, an important topic in field of heat transfer, and we've come across this numerous times in our NVIDIA class as well. This phenomenon is accomplished by heat exchangers. It's a device and its application includes our daily lives, from residential home to nuclear fields, boiler, fan coolers, cooling water heat exchangers, and condensers are some examples. Basically, its design consists of two fluids separated by some conducting medium, and heat is transferred to convection or by conduction, and major parameter right here is heat transfer coefficient, which depends upon this four basic subparameters. Moving on, we have the types of heat exchangers. This one right here is cross flow, where flow of two streams is right angle to each other. Then we have inline, where flow of stream is parallel. Under inline we have parallel, where cold fluid and hot fluid are parallel to each other. This is the temperature difference graph on the right. And then we have the counterflow, where cold fluid and hot fluid are moving opposite each other. During this experiment, we're told to determine the overall heat transfer coefficient using LMTD method, correlation equations, and then told to analyze effectiveness and analyze the behavior and characteristic. We have the LMTD method right here, where U equals to flow rate, heat transfer flow rate over area times temperature difference, and the flow rate depends upon this relation right here, and the notations are given right here. We then have correlation equation, where U equals to 1 over 1 by heat transfer of hot fluid plus 1 by heat transfer of the cold fluid. This both are the heat transfer coefficient and depends upon this relation right here, Nusselt's number times thermal conductivity over diameter. And these notations, description of these notations are right here. And note that the Reynolds number was a major factor here, so as to determine whether the flow of the hot fluid or the cold fluid was turbulent or laminar. And all the properties here and properties before in the LMTD method was evaluated at mean temperature. We have the setup of the heat exchanger right here. The cold water comes in from this part here. Valve bed controls the flow of cold water, opens and shuts down, and hot water comes in here. The main source of hot water comes in from here, valve 2 with the main valve for the close or opening of the hot water. This is the heat transfer surface right here. These 4 dots right here are thermocouples to measure the temperature. And we have flow meters right here. Flow meters evaluate the flow rates of hot hot water and the cold water respectively. We also have a dial mark 1, 2, 3, 4, not shown here, which depicts the temperature according to the numbers. That is, if you press 1 on the dial, shows temperature of this thermocouple right here. Then we have a listing of the procedures right here, and the results we obtain, the transfer rate and the overall heat transfer coefficient obtained from both methods. And this is the graph we plotted in MATLAB program using some codes, and we see that the counterflow and parallel flow have the same heat transfer rate, almost same. This is the graph for overall heat transfer, both LMTD and correlation, and both parallel and counterflow have same heat transfer coefficient. And coming to conclusions, we see that overall heat transfer is both similar to both methods, but overall heat transfer in LMTD method is significantly less than that in correlation equations, and there are some errors in the experiment we have done, which we can attribute to these factors right here. Increase in mass flow rate increases heat transfer rate and heat transfer coefficient. Counterflow is slightly better, but we cannot really determine differences. References I took from various websites, and thank you for your time.